Why open innovation for us? So it's one of those things that the Joy's Law comment that people always quote a lot, that the smartest people work for somebody else, no matter how smart you are. And when you say that at NASA, it's kind of an interesting response that we get from our own engineering community, because you think we hire the smartest. We don't always. We can't hire them all. You can't move knowledge into a government agency or even into our contractors that we want. So how do we actually find those right people to help solve our problems that we have? And you'll see these here. So we have everything from our Centennial Challenge program. So we're building real things. Like we actually run challenges for building rockets and having people actually build rockets that can do suborbital flights, and they win $1 million for that. We have other challenges where we're building green aviation, where the challenge is actually folks building real aircraft for prize money for the most efficient electric airplane ever built. We have other things, and I'm going to go into this one more in depth today, which is NASA Tournament Lab, which is on software and algorithms and actually writing the code that we need for various systems and software systems we have. We actually supply a lot of our support to other government agencies. The government's slowly getting into this. And you'll hear from Karen tomorrow, more from GSA, on the broader government and kind of impact that open innovation is having across everybody. We actually use crowdsourcing internally. We have a platform called NASA at Work, and how do we post challenges from one center to another? NASA's a big organization. We have 10 centers across the country, hundreds of thousands of employees and contractors that work for us. How do we actually access the talent we already have? How do you know the guy down the hall, what he's doing? Can he actually help you solve the problem as well? We do a whole series of educational challenges and other things in the maker space, things like our International Space Apps Challenge, and it really heavily involved in that area as well. So how did we get started? So we actually ran a series of pilots. So you heard from others already about, we had diminishing budgets. One of our specific places was at NASA Johnson Space Center in Houston, a very famous location for NASA. Our human health and science folks, we're seeing budget cuts of 20–30% year over year on their research budgets. So we said, well, how do we figure out how to collaborate with others and be able to leverage the outside talent to accelerate the tools that we have? We're not the only ones that need human health and performance type characteristics. So we actually ran through a whole series of pilots, which is something I'd highly recommend for any organization. Starting out with a whole series of pilots where you can fail. We actually chose, the list that you see here is our first round of challenges. And we chose them because we didn't actually have answers for them at the time. You'll see the ones here for food packaging. How do you package food and put it on the shelf for 5 years, besides Twinkies, that will actually last that entire time? We need food packaging that will go for that long of a period of time for deep space, trips to Mars and such. And we actually have worked with every single food manufacturer, the military, MRE type folks and all that over the years, and we were striking out on any kind of barrier layers for food packaging that would get us to that deadline. So we actually ran a challenge for that, and we discovered a material that was from a material researcher in Russia. It's a flexible graphite composite. It had never been used in food, but it actually had all the properties of it. And now we actually have that food packaging material in testing today, and we got that solution through a challenge. You'll see the whole list here, and it was pretty interesting for us. But one of the things that came out of this is we learned a lot in these pilots. One of the things is NASA's brand appeal was actually very good for us. We had high rates of participation from around the globe. So over 80 countries. Our one software challenges there we ran, which was a medical kit packing algorithm. We had over 2,800 algorithms submitted in 1 week for that optimization of that piece of code. We had over 8,000 people participating online in our internal NASA at Work area, and then our innovation pavilion, which is where we run non-software challenges, over 2,900 solvers over 4 challenges that we had around the world. You heard this from the others. If you look at how you define a problem, we spend a lot of time in defining the problem statements. How do you write a problem statement that a non-domain expert can actually solve? So somebody, if you're writing a materials problem or a food packaging problem, they may know nothing about food packaging, but they do know about materials that don't allow oxygen to transfer over through the material. So we write our problem statements in more generic ways to allow multiple domains and multiple disciplines to attack that problem. The medical kit challenge that we ran, we have our crews that we send into space. We know their health characteristics, and we know the environment we're sending them into. So that gives us a set of risks that we know that we're sending an individual into. And to mitigate those risks, you know that you can bring certain medical techniques, medicines, surgery equipment, and those kind of things, depending on where you're going. But we also have to cram that all into a space that's less than the size of the stage in order to get all that packed up to be able to send on a deep space mission somewhere. So we had to overly constrain the problem. How do you meet the most of the risks with the medical equipment such as you're packing in the smallest volume and the smallest mass? So, and how do you optimize the best solution set that you bring with you? And so it was basically a math problem, not a medical problem anymore. It was basically, it's equivalent of like a traveling salesman optimization algorithm that a lot of computer scientists work on. So spending a lot of time in that problem definition was very important for us. One of the things that hit us right off the bat after running our pilots, and this is the first thing we did as more of a permanent platform at NASA, is that software and algorithms were different. And different in that there's a different community that likes to participate in those types of challenges. There's different tools. If you get those 100,000 solutions sent in, how do you know the Java code versus the C code versus the Python code? Which one's better? Never mind all the code language battles of which one's better. How do you benchmark that to figure out which code solution is the best? So we actually formed an activity called NASA Terminal Lab. This was actually formed as a contract with Harvard University, and Top Coder is here with us today. And Top Coder had a unique platform and community of software developers that we wanted to leverage. Going back to those other platforms, we actively chose this as a way to implement, in that we did not want to stand up our own platform. We, NASA, didn't want to write a software challenge platform. Why not use somebody else's? We're going to have challenges come and go. They're not going to be active all the time, although we do run challenges pretty often at this pace. But somebody else can care and feed that community for us and give them other interesting challenges to work on when we're not running our challenges. So what we wanted to get at with Tournament Lab, and mainly for software in this case, but this analogy works for everything else. So I actually disagree with some of the other speakers on R&D. We've been using open innovation for R&D, but you have to be very careful on how you do it. This is your standard funnel for R&D projects. It's wrong. If any of you guys as chief technology officers or technologist type folks would give you this is wrong. And it's wrong for a couple reasons. Because you have those lines in the middle, and these are usually decision gates of some form or another. So you can only allow so many projects to come through, and you have a decision gate, and you only allow so many to keep on going through the next gate, and you end up with one at the end. The problem is you can't afford to send more than 3 or 4 through that loop. And crowdsourcing is what enables us to actually allow more than that to come through the loop. So what we're doing here, and this is more of a statistics kind of standard statistics curve here, is we are trying to get those best solutions, those extreme value solutions. You look at a pipeline approach, you think you're getting the best extreme value solution out of your decision processes, but you want to get over to the far right-hand side of the curve, beyond the Six Sigma kind of portion of the curve there, and how do you get that extreme value piece? Well, statistics will tell you that the way to get that is the most draws on the problem. So the more N you have, then you're going to be able to get the highest likelihood of getting those extreme value solutions. Well, the other chart said you have to down select your N at every single gate. So we stood up NASA Tournament Lab to do 2 things. It was creating novel and high quality software code and algorithms for us. But the other part is we also understood that we're not smart enough to actually understand open innovation at this point. So we're actually running a series of experiments, and they're being published in peer-reviewed literature from our postdoctorates at Harvard University and MIT and a couple other places on the actual science of tournaments and what gets people to participate. Why do non-domain experts actually do better? Why do women do better on challenges? All those are actually true findings that we've seen. The other side of it is we've been doing research on how peer review is completely broken. So there's actually a recent published paper by Harvard and the Harvard Medical School folks on showing that peer review, which is like the way R&D research is selected across the country, especially in the government, actually doesn't work at all. And doing that, gathering that data through innovation. But learning that data and sharing it with a wide community has been one of our focuses as well. So NASA Tournament Lab, we're focusing on image processing algorithms, optimization type things, user interface design. In fact, our entire platform for NASA Tournament Lab was built through challenges. The slide deck you're looking at was built through a challenge. So we're actually living and breathing everything we have been trying to do with the platform. All of our graphics were done by challenges, everything you see here. So it's an interesting process that we have here. And I'm going to go into a couple specific examples. So we've been running a whole series of software and algorithm challenges. One of the recent ones, we're going into a whole series around the space station. So we have a space station overhead, 6 people on it every single day of the year. There's actually a launch from Kennedy Space Center on Friday with SpaceX taking another cargo flight up. Launches at 10:10 on Friday morning, docking on Saturday morning with the space station. But one of the things that we were looking at is, how do we use challenges to actually optimize science and scientific return in the space station? And part of that is some of the algorithms for things like, how do we optimize our power production? It's not like NASA couldn't do it, but it wasn't something that was a high priority for us because we have a solution today, but how could we make it better? And we used a crowdsourcing challenge to do that. So what we ended up doing is an algorithm challenge. You see the space station up in the right-hand corner here. All those solar rays can turn in 3 dimensions. They can rotate around it, so they all have different joints and such. And we wanted to have the most optimal position for them for shadowing effects while maximizing power production. So we ended up running a 3-week-long competition for 30 grand. What was amazing to us is we had over 4,000 people registered to compete on it. This is a pretty highly technical problem. We had over 450 people actively competing, and in the first week, they were approaching over the 98% cost theoretical efficiency level in the first week alone. And over that next 2 weeks, they kind of dialed in the final solution. What we're at now is analyzing. This literally closed about 2 weeks ago, and now we're doing detailed analysis of how much better their algorithm was than what we had today. And depending on that outcome, we'll actually put it into operations on the space station, which is an interesting question. So when we announced NASA Terminal Lab, we were at an event called the Top Coder Open, which Top Coder that brings in the top 100 programmers from around the world every year in kind of an arena-style competition. And Kareem and I stood up and said, we want to start with you, the community, doing software challenges for NASA. The first question we got is, you're not actually going to fly the code that we write, are you? I said, yes, so please do a good job. And don't screw up our space station or anything else like this. And what has been really interesting is we get this really charged community from around the world of people participating and wanting to help NASA. Obviously, there's space agencies around the world, but NASA is kind of seen as the space agency of the world. And a lot of the other folks that we partner with around the world want to be like NASA's space agency. So a lot of people, we're kind of your space agency, not just yours in the United States, but the world as well. And it kind of shows with the community participation that we're seeing today on our platforms. So we're also doing things beyond algorithms. So you heard a little bit this morning about how do you do segmentation and breaking the counter challenge. How do you write a problem statement that is the right size for the community that you're working with? And if you think about software, software is nothing but a series of small tasks that need to be written and then integrated over time. So if you take each one of those small tasks and divide them into a challenge, you can actually write an entire software suite. So another challenge that we're doing for software development, this is actually ongoing right now, so you could actually write code for this challenge if you felt desired to, is we're writing a food intake tracker. So we have our astronauts on board the space station, and they have to eat just like everybody else. But we also monitor their health effects. They're quite guinea pigs for us up there. We do blood samples, tissue samples, and all those kinds of things on it. But one of the problems we have is it's just like your kids or ourselves. What did you actually eat over a period of a week? Our astronauts will try to remember and write it down at the end of the week. That typically doesn't work all that well. Or everything's kind of pre-measured packets where they may not eat at all or those kind of things. So we actually don't know their calorie and such. So we wanted to build an application. Now there's tons of applications like this out there. But we wanted one for iPad, and we had a slightly different challenge for us in that whenever you have an iPad or some kind of tablet device in space, if I go to hit and push on the button, the pad flips the other direction. If I hold it and I push on it, I move with it. So touch screens are really a pain. So we think touch screens are the best thing ever down here, but in space, you have to have something to hold on to. If you ever see our crews on the space station, we have laptop terminals set up. What you don't see below them and on the floor are foot straps. And their feet are in a foot strap, so when they type on the keyboard, they don't float up. So they have to actually hold themselves down on their keyboard. Same thing with a tablet type device. So you'll see there's a whole progression of challenges that we're writing, and we want new intuitive interfaces. Can you use the camera to take pictures of the food? Can you take pictures of quantities and such, and can it do image processing in order to recognize how much food was eaten? So it's a slightly different challenge that we have. But you'll see here we're running a whole series of about 15 to 16 challenges here of every little component of this. And we're writing a full application that will later on this year we'll upload onto the iPads that we have on orbit, and we'll start using it to collect our data. We've already done similar competitions before. We actually wrote an ECG, an echocardiogram device. We have a 12-lead ECG that takes your heart rates and all those kind of things. It's in a vest kind of format, but we needed a user input on a tablet. And we actually wrote the entire user interface on that, and now we're using that for our ECG measurements on orbit. One of the things about being the government is we also release everything open source. I am a big anti-intellectual property person, especially in the government side. And all of our code solutions, everything we actually write is actually released open source back into the community, which our community really values as well. So even though they're submitting challenges and the ownership question kind of comes up, we actually make it accessible back to them, even the solutions they come up with, and put it back into the community, and which they highly value as well. So I wanted to branch out in a couple other areas, and this platform concept. We're also doing some really innovative things on other platforms. You hear, I don't have a slide on it today, but we have our NASA Innovation Pavilion. It is for our non-software type challenges. We've ran things from how to design a laundry machine that works in microgravity, to how to do prediction for solar events. Whenever the sun has a nice solar flare and that the energy starts coming towards Earth, how do you predict when that event will occur? And it's really important for us, and it's really important for folks here as well. But for us, our crew members in orbit could really be damaged or health effects. But it also interacts with our communication satellites and such. So major solar events, you'll see warnings for phone interruptions and those kind of things. But we're also doing more kind of creative art type things. So we did a work with Threadless. I don't know, who else heard of Threadless? Great. Great platform, Jake and all those guys. We were getting ready to fly the very last shuttle mission. So this was a kind of an emotional time for not only NASA, but the public as a whole. So we said, there's generations now that only knew shuttle. So can you actually communicate what the shuttle meant to you in the form of a t-shirt, and what the art is there? So actually in less than 2 days, I called Jake up and said, hey, can we run a challenge? And he said, sure. We put together the little challenge statement, put it out there, and then actually announced the challenge on the day of the launch. And had tons of ideas come in. These are just a few. They're actually still up on their website, and several of them have gone off to get printed and such. Which was really interesting to us. Is like if you go into a NASA gift store, there's some pretty cool gift shop stuff. I guarantee you won't be as cool as these things that came in. So the other side of it is look at all this creative, artistic work of what the space program meant to all these individuals that are on Threadless. The winning solution was this one. So the classical kind of backyard kid with his family there launching a rocket. So it's kind of neat. So the other area I wanted to talk about is we're also experimenting on other platforms like Tongle. So Tongle, some of the folks are here from Tongle. We actually ran a couple challenges here. The Tongle basically is video production. In fact, 2 other videos were at the Super Bowl commercials this year. In addition to the stuff that they do for all of our other clients. We wanted new ways to communicate NASA's mission and impact. One of them was the Venus Transit. Venus Transit occurred last year. It was one of those events that happens 100 and some years. We will not be alive to see it happen again. But we wanted to be able to create a video time capsule. So we actually set up a system for everybody in the world to be able to submit all their videos, all their images, anything they wanted to us online. And we collected all that data, video footage and everything else, and all their remarks and such on what the Venus transit and what the world was like on that day. And then we actually opened up all that content to the video challenge community on Tongle and said, create a time capsule for us that aggregates all this data in a short kind of 2 to 3 minute video. Another one we did was for Zero Robotics. So there's tons of robotics competitions out there. We have one called Zero Robotics. We like to think ours is pretty cool because the winners actually compete live on board the space station. So high school, middle school students program small little basketball-sized robots that we have that fly around on the inside of the space station. We run this as a middle school and high school program across the country and in Europe. And at the end of the day, the top 27 teams all come to a big arena, and we connect to them with video and audio to the space station live, load their code up, and actually run their robots in space. And the winning team is recognized for their achievements that they've done. What's really interesting about that, we started out as kind of an education thing, getting students to code and write software and such. Now what we're finding is the code solution that the students are writing, the optimization, the game that they're having, is actually better than some of the solutions that we've done for our real missions. So we're actually having high school, middle school students program next generation navigation algorithms that we've never actually written ourselves. So there's actually a couple PhDs now. There's a couple students at MIT that we convinced them to change their PhD to actually run and collect all the data through crowdsourcing for their PhD in aerospace engineering. And they're actually coming up with new algorithms through challenges, which is kind of an interesting thing. But we needed to, how do you make that kind of sexy and get kids to actually want to participate? So we created a whole series of videos through Tongle to actually help us promote involvement in the student competitions and try to drive that media and social media push on it. We had, in 4 days, we had about 1.5 million views, top 7 video that week, and we did our campaign for it right before we were doing signups for that year. So it was really impactful. So for us, we've been learning on all these different platforms on how to actually stitch together this entire capability across NASA. What's interesting to us is we've been doing crowdsourcing for literally tens of years at NASA, but this is probably the first real organized attempt that we've had on organizing across the entire organization, NASA. With that, we've been also working with other government agencies. You'll see here everything from Health and Human Services, Medicaid, to the Office of Personnel Management, to the EPA and such, and trying to teach those other government agencies how to do the same thing. So we're doing this with all the other government agencies there, but where is the limit? We chose not to do our own platform, but let the brand be the platform and build across everybody else's communities and help foster those communities to grow. I don't know where the limit is and how far we can take crowdsourcing, but we're definitely nowhere near the limit at this point. So I'm really encouraged to see where we're going with all this. There's tons of examples online. I barely scratched the surface of all the challenges and what we got going on. So looking forward to any questions you guys have in that area here in a little bit, or grab me after. I'll be here today and tomorrow as well. So with that, I'm all done. Thank you.